Hello guys, it's me Stanley from Photoneo. Welcome to the beam picking tutorials. Today I'm going to explain you how to set up vision systems in Beam Picking Studio for simple and more advanced automation tasks. To bind together workpiece, scanner, its position and localization profile, we go to Vision System page and click on Add New Vision System button. In the name we provide some descriptive name like a Vision System. It already has a unique ID, it's number 1. This ID is used when we call scan and get trajectory from the robotic program. The scanner ID is the scanner we will be using for picking of this workpiece. In my case it is one of available scanners 1709004 and it is PhoXi 3D Scanner M. The scanner is mounted on the robotic cell. It can be also mounted on robotic flange. In description I will put we will be using this vision system for picking of plastic T-fitting, for example. For the picked object it is full and we can create the localization profile straight away from the scratch or upload something we created in different vision controller or some colleague gave to us or something else. So by clicking on create new, the localization algorithm is loaded on the background and we can create a new one immediately using our scanner and the point cloud from the scenery. So the first thing is to start locate, to get the first scan, the first point cloud, and to run localization out of the box. I'm going to zoom in a little bit so we can see what is inside. The first thing we can notice is different colors, and the gray one is the background. The shades of green are basically the segments created in the beginning of the localization algorithm. We can choose a different color for the point cloud in this field in here. Using segmentation we can actually help localization a lot because the segmentation is a key for successful localization. In the first run we found 41 parts and they have some overlap number and they have some ID. By selecting a part we can visualize which part is which and also respective overlap percentage for them. For the localization there are a couple of basic settings and a couple of advanced settings. Each setting usually serves as a filter or some criteria. First criterion for localization is timeout. The algorithm is non-deterministic, so it can run forever unless we tell it to stop. Default value is 10 seconds. We can change it for some other value, and usually the process is we start localization, then we count how many pieces we find in how much time. In my case, most of the pieces, like 99%, are found in first 5 seconds, so I'm going to use only 5-second timeout, and afterwards I will free resources for different algorithms like path planning. The next one is overlap, which is value which combines the visible portion of the workpiece and ideal visible area of the workpiece. Let's say we have area of the workpiece of 10 centimeters square. When I'm looking at the piece from the top, I can see at most 4.5 centimeters squared, and my scanner see only 4 centimeters squared, which is 90% of the surface. The overlap would be 90%. If we see less, the number drops. So this is a good criterion to actually get only the most visible pieces, like I will put 80 and suddenly I will not see 41 parts, but I'm going to see a little bit less, like the 12 parts only, because all the others have at less than 80% of the overlap. The matching algorithm is to search for the features of the workpiece, and those features are the curvatures of the surface or clearly visible edges or something in between. So if my workpiece is curved, it has nice features, I will use the surfaces algorithm. If it is a sheet, like sheet metal, cardboard or something similar, then we usually go for the edges matching algorithm. And the scene clustering level as the last from the simple parameters is something which is telling us how much we should cluster the scenery before we start to find the parts in it. And the low is going for low number of clusters, the very high is going for a very high number of clusters. If I am satisfied with my results, I can save the configuration, and if the PLC file is generated, I can quit localization because it is already saved into my vision system. Right now we can see also calibration matrix, which is empty. It is identity matrix, which is telling us the scanner position as at the base of the robot, which is a nonsense, but the calibration matrix will be filled out during the calibration process. So I am satisfied with this vision system. It is simple vision system for one scanner, one workpiece, one position of the scanner and one configuration, and I'm going to save it. If we have multiple scanners, multiple scanner positions, multiple workpieces, or just simply multiple localization profiles, then we need to create similar vision systems for each combination. Either you have single part with one scanner and one bin, or you have multiple workpieces and multiple scanners. Bin Picking Studio has a solution for you. Thank you for watching. If you like this video, don't forget to watch other tutorials and also subscribe to our channel. See you soon.